Hello everyone, welcome back to this lesson. So our today's lesson is based on annuities. It's just continuation. This is our lesson number 3. Okay, let's start with example 1. And Dumi starts a 5-year savings plan. He deposits 5,000 into savings account at the end of every month. The interest rate on the account is 6% per annum, compounded monthly. So now, before we even continue, by having this end of every month, then which means now we're dealing with an annuity, right? The interest rate on the account is 6% per annum compounded quarterly. Now they are saying determine the nominal monthly interest rate which Indomie receives. So in grade 11, we taught you how to convert from nominal to effective or or effective to nominal, right? So there's a formula that you need to use. So now let's just go back and use that formula. So for A, we have the formula 1 plus I new and then 1 plus I norm and then n. So now you have your 1 plus I new divided. Determine the nominal monthly interest. So we divide by 12. Because of monthly, we use 12 there. And then 1 plus the interest rate on the account is 6% per annum compounded quarterly. So you divide that 6 by 100 and then you get 0.06, right? And then here we use 0.06. Now divided by what? By 4 because of the quarterly here. And then there's 4 there. And then as from here, now you have to get rid of the brackets now, right? So you have your 1 plus I new over 12 equals to, we take the 12th root, both sides. We take the 12th root, yeah? So now you'll have a 12th root of 1 plus 0.06 divided by, divided by 4 all to the power 4, right? And then now you have your I new now you have your 1 plus 0.06 divided by 4 all to the power 4 minus 1. So now we have to transpose this one. You transpose this one. And then you end up having your -1 there, right? And then from here, you multiply both sides now. Now you multiply both sides by 12 and then by 12. You multiply everything here by 12, right? And then you'll end up with your I new is equals to 0.0597, right? And then we can say that therefore your I new, now you multiply whatever that you got by 100. And then you get your 5.9 7% per annum compounded monthly. Perfect. And then now we've answered our A, right? So now we have to answer our B. Determine the amount Indomie will receive at the end of 5-year period. Okay. So here we take out your data. So your X is equals to 5,000. Your I is 0,0597. Um, and then what else do we need? N, number of payments. Number of payments, let's see, it's 5-year period, right? 5-year period, it's not a problem. So you'll have your 6 times 12, which is equals to 60. That's your N. And then we can say, therefore, future value is equals to your X, 1 plus your I, N minus 1 divided by I. And then from here, you plug in your information. So now you have your 5,000 there. Zero comma 0,0597 divided by 12. 60 minus 1. 0,0597 divided by 12. And then what do we get? And then for our future value, we get 348,581, right? And then, so it's important for you guys to conclude when it comes to financial maths. So you have to say, therefore, after 5 years, he will have this amount. Perfect. Now let's move to example 2. Let's move to example 2, right? But now, before we move to example 2, ne? Question B, ne? B. They're saying determine the amount Ndumi will receive at the end of 5-year period, right? And then now, but if you can check something, they're saying he deposits 5,000 at the end of every month, right? So now the reason why we decided to use this percent compounded monthly because he deposits end of every month. That's why we decided to use that one. instead of the one where it's quarterly. That's why we decided to use this interest. I hope we understand that part. Now let's move to example 2. Example 2, they're saying Ahmed deposits 2,000 into savings account at the end of every quarter for 16 years. The account offers an interest rate of 8.5% per annum compounded quarterly. Due to financial difficulty, he is unable to make his last 2 payments. How much will he have in his account after 16 years? Okay. Ahmed deposit 2,000 into savings account at the end of every quarter for 16 years. Okay, cool. Quarter. So for quarterly, we use 4, ne? We use 4. So, and number of deposits, how many deposits did this person make, right? Now for 16 years, which means we need to say 4 times 16 there. So basically we need to get 60, sorry, we need to get 64 deposits, ne? 64 deposits. But now they are saying due to financial difficulty, he is unable to make his last 2 payments. So which means now we need to say 64 minus 2 because this is just what number of payments. And then you get your 62. So which means now your n is equals to 62, right? Your n is equals to 62, and then your x is equals to 2,000. And then what else? Oh, your I, we divide this by 100. Now it's 0.085. Compounded quarterly divide by 4, right? Now let's plug in the information. So you have your F, V is equals to, let's start with the formula there. So we have your 1 plus I, and then there's 1 there, or there's N minus 1, all divided by I, right? So now, in place of X, now we substitute 2,000, 1 plus, this is our I, so you have your 0.085 divided by 4 because of quarterly. Now the number of payments, you have 62 because the person missed 2 payments, right? And then you will get your 252,506, and then uh, this is the amount for only 62 payments, right? This is the amount, right? But then now, remember now, if the person doesn't pay, it doesn't mean that it doesn't mean that this will not accumulate any interest. It doesn't mean that it will not accumulate any interest, right? So now, since he couldn't pay for 2, uh, actually, since he couldn't make the last 2 payments, then we can conclude to say this amount accumulated an interest for 2 quarters. I hope you understand that part. So with that being said, we can now use the formula. This is still the formula for a future value. This is still a formula for future value. So this will be our principal amount Another thing, guys, after getting your answer, please do not round off. Do not round off anything. Do not round off anything. So 1 plus, still use the same interest, but now for last two payments. So we use 2 there for last two payments. And then for A, we get we get 263,352, right? And then after you conclude, so it is important for you to conclude. So we say, therefore, he will have this amount after 16 years. Perfect. This is example 2. Now let's move to example 3. Example 3, at the beginning of January, a factory purchases a new delivery truck, which they expect to replace in 5 years' time. In order to replace the truck, the company will need 200,000 after trading in the current vehicle. What monthly payments must be made into a sinking fund, which provides an interest rate of 6.25 per annum compounded monthly if payments start 4 months after the original vehicle is initially purchased? Okay, cool. We also need analysis, but I feel like now this will need a timeline, grade 11 timeline, right? And this is about a sinking fund, right? So now, in normal sinking fund calculation, the first payment is made 1 month after the purchase of the vehicle, usually, right? But here, they are saying the payment was made 4 months after. So which means they've skipped 3 payments. Which means they've skipped 3 payments. Because normally for a sinking fund, uh, the first payment is made 1 month after the purchase of the vehicle, usually. But then here, it was made 4 months after. So which means they've missed 3 payments. So now, we need to use a timeline. We need to use a timeline. Let me try and draw a timeline for you guys. So 1 month. Let me just say 1 month later. Okay. This is January, right? This is January. So you have a Jan, I'll just write Jan and then first. Perfect. And then 2 months later, 2 months later. So this is my timeline. This is Jan 31st. So here what happened? They missed payment. They missed payment, right? And then let's continue. So you have your 3 months later here. 3 months later. This is Feb 28. Again, they missed a payment here. And then March 31st. They missed a payment again. So we're just analyzing this here. So 4 months later, 4 months later, which is April 30th, they've started making the payment. That's when they started making the payment. And then it continues like that, right? So we have to actually get our sinking fund. We must calculate our sinking fund. So now how do we go about calculating our sinking fund, right? They are saying, okay, let's go back to N. Now let's try to get our N. 5 years time, compounded monthly, right? So your N would be 5 times 12. That's just 60, right? But then now this person missed 3 payments. So this is just 57, your N. So our N for a sinking fund would be 57, 100%. Now, okay, we're looking for our X. So our X is anonymous, right? So now how can we get our X? So, okay, cool, let me do this. You have your future value equals to X 1 plus I and minus 1 divided by I. So now we can see therefore the future value is 200,000 equals to, we're looking for X 1 plus divide by 100 divide by 100. So you'll have your 0.0625 compounded monthly. So we divide by 12 and then we use 57 for N because they've missed 3 payments. They've started 4 months later, right? This is our I again. So this will be 200,000. Now you multiply both sides by 0.0625 divided by 12, right? And then you'll be left with what? 1 plus 0.0625. So here you are just applying your mathematical gymnastics. 57 minus 1. And then there's x there. So we divide both sides. By 1 plus 0.0625 divided by 12, 57 minus 1. So now we want to isolate x now. So obviously here you apply your algebra. Here you apply your algebra. Just make sure that you don't make any mistake when it comes to algebra. So and then from here, we cancel both sides. And then we can see, therefore, your x is equals to 3022. Correct. Guys, we've come to the end of our session. Thank you so much for watching my video. Bye.